Hey GED students, I'm super excited about this problem and have been wanting to tackle it with you because looks easy, but there's a really crucial thing that students forget and give themselves a wrong answer here. Okay, so let's go ahead and take a look here. It says, translate the phrase into an algebraic expression, the cube of -2/3 j. Now, this being said, yes, this is in the basic ops lesson, but this is in the advanced level practice for a few reasons. You would need to have already had experience with the word cube. That's not one of the 4 basic operations. We're getting a little more complex now. We're talking about exponents. And you'd have to have a little bit of practice with negatives in order to fully understand this. Also, you have to not panic at the sight of the letter J, okay? So if that's you and you're panicking at the sight of the letter J and you kind of want to puke, now's not the time for this. Go ahead, turn off this video. But I want to translate this into an algebraic expression. Now, the main thing that I wanted to cover here is not really about the word cube. I think most of you guys, if you're advanced students, you're experienced students, you're used to cube, you know cube means the same as the 3rd power, or that little floating 3. But I think what most of you would do is you just go, okay, -2/3 j cubed. And if you did that, you would be wrong, because remember that exponents are super duper weak. They only act on the number that they're directly attached to. So if you say -2/3 j and you write it like this, what you're saying is cube j and then multiply your answer by -2/3. You might be saying, well, how am I supposed to know that, Kate? Order of operations, guys. Y'all told me you're experienced students. Order of operations would say that we would do any exponents before multiplication and division. So that's how that particular problem would be. That would be the cube of j times -2/3. The cube of j times -2/3. Or, I mean, that's not the only way to say that. You could also say the product of -2/3 and j cubed. There's a lot of different ways to say that, but nonetheless, it doesn't express what this phrase expresses, which is that I want you to cube this whole thing. I'm going to say that again. I want you to cube this whole thing. I want you to cube something that has operations in it already. It's a grouping, guys. And so you are going to have to use some kind of a thing to group -2/3 j all together before you cube it. So easy way, we just use parentheses. Slap that whole sucker in parentheses, close it, then cube the outside. And now what I'm saying is cube this whole group. Not just cube j, but cube all of the number as the phrase told me to. Cube the entire -2/3 j. Okay, so this is a little messy, so let me rewrite it. So it's super neat, so you can see your final answer. So I get -2/3 j cubed. And you might say, but can't I simplify that? Yeah, you could simplify that, but I'm not asking you to do that in this problem, so don't stress. I'm literally just asking you to write the expression, okay? And I didn't even say simplify. I just said translate. Don't worry about it. This is the answer I was looking for. And again, this actually is really an extension of a GED skill. I've never seen one just like this on the GED. Now, don't get me wrong. I've seen cubes. I've seen negative numbers. I've seen this grouping idea, the order of operations. I see translating the phrase into an algebraic expression. I just have never seen one quite like this where all those things are combined. So don't panic about it, but this is very applicable in understanding that we need to group an entire number together before our exponent will work on all of it. So if we want our exponent to work on all of it, we need to use parentheses for grouping. All right, if you have any questions about this or any other GED math topic, be sure to drop it in the comments and I'll do my best to answer it.